Hello everyone, my name is Priyanka and I welcome you all to my session. Let's go for our question which says that use Gauss law to prove that the electric field inside a uniformly charged spherical shell is zero. Okay, so this is a standard derivation and of course the most important one. So let's just go for it step by step. So first we have to consider a hollow charged conducting sphere of radius capital R and having charge Q. So let's just draw this first. So let us take this. Okay. So this is the sphere and it is having a radius. Of like capital R. To find E at a point P inside the shell, consider a sphere through point P and having the center O. So we have to make one more sphere. Okay, so let this point, just a second, alright. So let this be the center of the sphere O and let this be some random point P on this inside spherical inside shell, and it is having a radius of small r. This was our capital R, that is the radius of the main shell. So the charge on this shell, which was a conducting shell, is going to be outside the shell as it is a conducting one. Okay, so we can see here that the small r is equal to OP. Now the electric flux through the Gaussian surface, flux phi, is equal to the closed integral of E dot ds, which is equal to E into 4 pi r square. And what's this 4 pi r square? It is the surface area of this small shell, that is of small r radius. As per the Gauss theorem, the total electric flux should be equal to phi. It should also be equal to 1 upon epsilon naught times the total charge enclosed. So what is the charge enclosed inside this small shell? It is 0. So what we can do is that let's just name it as 1 and the other is 2. We're going to equate both these flux. So E into 4 pi r square is equal to 0, which implies that E is equal to 0, which proves that the electric field inside a uniformly charged spherical shell is 0. So thank you so much for your time. Have a great day. Bye bye.